This lesson is Lesson 5, Division Property of Exponents. Today you'll be able to divide powers with the same base and take a quotient, which is a division problem, and raise it to a power. So we want to start our discussion with an exploration, and we do that by looking at a table and filling it in and noticing any patterns that we see. So we're studying division of powers or quotients. So our first example is worked out for us. We have x to the 7th over x to the 3rd. And when we expand out x to the 7th, you can see that 7 x's being multiplied by each other. And then when we expand x to the 3rd, that's in the denominator, and there's 3 x's in the denominator. Now, when they say the simplified product, what I need you to imagine is that anything that cancels. So if we have x over x, 1x divided by 1x is equal to 1. So we have 3 x's that are going to cancel out, simply leaving us with 1, 2, 3, 4 x's up on the top in the numerator. So there are 4 factors left. So when we started with 7 on top and 3 on the bottom, there were 4 left, and our quotient, or our answer, is x to the 4th. So if we expand the next one in much the same way, I take b to the 5th and expand it on the top, so that's 5 b's, and then 8 b's on the bottom, 6, 7, 8. And then we see what cancels. Well, 5 of the b's, all 5 of the b's from the top cancel, with 5 of the b's from the bottom. So we're left with 3 b's on the bottom. And when there's nothing left on top, we give it a placeholder of a 1. So how many factors are left? Well, there's 3 left, but they happen to be on the bottom. So how do we deal with that? How do we write an exponent or a power that's on the bottom? We could think of it as b to the negative 3rd, or 1 over b to the 3rd. And so now we're going to see what happens when we have a product divided by another product containing some exponents with the same bases. So I'm going to go ahead and factor my 6. So I'm going to think of 6 as 3 times 2. And then I still have those 5 a's because it's a to the 5th. And then in the denominator, I just have a 2 and then 9 a's. So there's 3, 6, 9. So when I think about what cancels, and let me get another color marker, not only do some a's cancel, my 2's cancel. So here, let's go 1, 2, 3, 4, 5 a's. So there's nothing but a 3 left over on the top. And then I have no numbers, but I have 1, 2, 3, 4 a's. 3 over a to the 4th. And so that's actually going to be my final answer. The 3 is left, and the a to the 4th. So if I want to say the number of factors that are left, that would be like an a to the negative 4 or negative 4 factors. So do you see a shortcut that could get you from the original problem to the answer without the middle 2 columns? And hopefully you've been noticing as we've been canceling them out, 5 minus 9 is negative 4, or an a to the 4th that's in the denominator. 5 minus 8 is negative 3, or 3 b's that are in the denominator. When I have the larger number on top, 7 minus 3, that gives me a positive 4, so I end up with a positive exponent. So in words, the pattern is that you subtract the exponents. And so let's say we have a to some power m on top, a to some power n on the bottom. The result will be a to the m minus n. So even though it's a division problem, you can use subtraction of the exponents as a shortcut. So let's do a few examples. We're going to say we have an x to the 8th on top, x to the 3rd on the bottom. We're going to use our subtraction shortcut, and we get x to the 5th for our final answer. Here we have a couple of different variables, but the rule doesn't change. I have m to the 2 minus 5, n to the 4 minus 3. That's if I expand it out. So 2 minus 5 is negative 3, 4 minus 3 is 1. So keeping in mind that a negative exponent will have that reciprocal property, n to the first can stay on the top, but m to the negative third is going to go down to the bottom. And let me scoop my paper up so you can see the work for that one. Sorry about that one. So you can see here I expanded it out. I wrote my subtraction problem for my m's, my subtraction problem for my n's, and then I worked them out. So now it's your turn. Here are some try it problems. Please pause the video and try them on your own before you check your answer. And welcome back. Let's check A through E. I've got a y to the 5 minus 4, or just plain old y. I've got d to the 3 minus 9, which is d to the negative 6th, which is 1 over d to the 6th. Here I have a few different variables. K to the 6 minus 1, j to the 2 minus 5. So that is k to the 5th, j to the negative 3rd. And final answer, I'm going to keep k to the 5th on top and move my negative 3rd to the bottom. Keep going. We've got a to the negative 3 minus 5, b to the 7 minus 2. So negative 3 minus 5 is negative 8, b to the 5th. So my b to the 5th stays on top. My a to the negative 8th goes to the bottom and loses the negative. So here I've got, for letter E, x to the 4 minus 4, or 0, y to the negative 1, minus 5, and z to the 8 minus 1. So x to the 0, we could write that out as a 1, or we know that 1 times anything is equal to itself. Then negative 1 minus 5, I'm going to add the opposite here. I get y to the 4th, z to the 7th. And that is my final answer. So now, let's see what happens when we raise a quotient to a power. So that's a division problem that's already formed, and you raise it to the power. We're going to use the property of raising a quotient to a power. So let's write that out. So if I have a over b raised to the m, then a over b raised to the m, I get a to the m over b to the m. So here I've got z to the 4th over 5 raised to the 3rd, and I want to take each one of those and raise it to that 3rd power, because that 3rd power is outside the parentheses and it's being applied to everything inside. So here I've got a power to a power, so z to the 12th, and then 5 cubed is 125. On my next problem, I'll have 4 to the negative 2nd, and then x to the 3rd to the negative 2nd. So the best way to do that, well, let me go ahead and multiply this 3 times negative 2. So I've got 4 to the negative 2nd and x to the negative 6th. So I've got two numbers with reciprocal properties in a division problem. So this x to the negative 6th is going to move to the numerator. And this 4 to the negative 2nd is going to go to the denominator. And once I've got all my exponents are positive, I could go ahead and expand that out into a 16 if I wanted to. But then what if that quotient is being raised to a negative power? Well, we kind of just saw an example of that. We've got our quotient, we're being raised to a negative power. One thing I could do is go ahead and flip it before I even start, and then raise it. Then it would be raised to a positive power. So let's try that. Let's look at example 3. I see here that I have this negative power. So I'm going to go ahead and take the reciprocal of what's inside the parentheses, and then once I've done the reciprocal, I can just take it to the positive 3 power. So y to the 4th to the 3rd is going to be y to the 12th. And then down here at the bottom I've got 2 to the 3rd and x to the 6th to the 3rd, which would be 6 times 3, using the rule. So I end up with y to the 12th, and then 2 to the 3rd. If I put that in my calculator, that is an 8, and then x to the 6 times 3 is the 18th. So now it's your turn. Let's see what you can do with this one little try it. Go ahead and pause the video, and then when we come back, we'll work it out. Welcome back. Hopefully you've paused the video and worked this out yourself. I'm going to use the technique described in the prior example. So if I have a quotient, something that is a division problem, and it's being raised to a negative exponent, I can go ahead and flip-flop what's inside before, and then I would, after I flip-flop it, that means I'm dealing with the negative, so I'm getting rid of that negative power. Now I just have to do 5b squared and a squared. So notice I kept the 5b in parentheses. That's to help me remember that that squaring goes with both the 5 and the b. So 5 squared b squared a squared. Final answer 25 b to the 10th over a squared. And that concludes our lesson on taking quotients using exponents. Thanks for watching.